typically, when we talk about AA, the idea here is that we're going to be looking at the angle-angle similarity postulate and really how that relates with everything that we've been looking at. So barely what this says is if two angles of one triangle are congruent to two angles of another triangle, then the two triangles are similar. Well, if you have two angles that are congruent, say like one is 45 and one is 90, and you have another triangle that's 45 and 90, well, you automatically know that the third one is going to be whatever helps this guy sum up to 180 degrees. So that means this has to be 45 degrees. And this one right here would also, because they have to sum to 180, also has to be 45 degrees. So really, if you have two angles, you really have all three angles of a triangle, as long as you use the triangle sum theorem. So basically what this is saying, the angle-angle similarity postulate says that if you have two angles, really three angles, then the two triangles are similar. Okay, use a diagram to complete the statement. Triangle ABC is similar to triangle what? Triangle A, angle A has two angle arcs, so I would have to look at the one that has two angle arcs, which is D. B has no angle arcs, so I'll have to say that's E. And then the one that has one is going to be F, so D, E, F. Number two, we have a statement of proportionality. So how does AB prepare? AB is the side that is like this, so that's going to be over DE. That's going to be equal to something over EF. So EF, that's the second two letters, so that'll be BC, and that'll be equal to CA over CA is the last and the first, so that'd be FD. Just writing out a statement of proportionality. Number three, angle B is going to be congruent to, this is B down here, that would have to be angle E. Number four, something over 12 is going to equal 8 over something. So the something over 12, probably we're going to be looking at x over 12, and then we're going to be looking at 8 over y. Now I don't think that's something that we can necessarily solve right now, but maybe a little bit later on we can. Number five, x equals. So in order to do this, we really need to have two sides that are two corresponding sides that are congruent or that are similar. So we'll say 6 to 16 is going to be equal to x over 12, because we're picking something from the top, something from the bottom, something from the top, something from the bottom. They have to be corresponding for between the top and the bottom. So we'll cross multiply. 6 times 12 is 72. We have 72 equals 16x. When we divide that in our calculators, we simply get that x equals 4.5, and we don't have any units, so maybe we just say units. Okay. Number six, y equals, again we'll have to come up with something to relate these. We'll just use 6 over 16 equals, the y is related to this 8, so we'll say 8 over y. We cross multiply, we have 6y equals, let's see, 16 times 8, kind of a big number, it's 128. We'll divide 128 by 6, and we should get 21 1/3, so we can write 21 1/3, something like that, or 21.3 is what some people will write units. Okay? Determine whether the triangles are similar. If they are, write a similarity statement. What we really need to do is we need to find the third angle. They kind of give us two angles, but they're not necessarily the ones that are related. So in this case, the angle that I need is going to be 50. This one's going to be 45. It looks like there is a 50, 45, and 85 in this diagrams in both of them. So I'll just label this angle JKL is similar to, let's see, J is 45, so I'm going to need angle Y, which is 45. K is 50, so I'll need angle Z. And then L is 85, so I'll need X over here. Not necessarily both in alphabetical order, but order does matter. Number 10, I know that angle J equals angle J, and because these are parallel lines, I can then say the corresponding angles are congruent. So really I can say all three of these angles congruent to each other. So if we said this angle or triangle J, LM is going to be similar to triangle JKL. N, something like that. In this triangle, we're both sharing angle 50, and then we have 45 here. We have 85 down here. Really trying to figure out what's going to go on here. If we have 50 plus 45, that does give us 95. I mean, this angle right in here has to be 85 degrees. So then for the big triangle, we have 50, 85. This one has to be 45 degrees. So though these triangles don't look similar at all, they technically are. So we have triangle P, and we'll say PQT is going to be similar to triangle P, because that's the 50-degree angle. Q was a 45-degree angle, so then we have to say S. And T was an 85-degree angle, so we have to say R. Okay. Number 12, let's see. These two lines are parallel. These are vertical angles. So we have vertical angles, and this looks like we have a transversal that kind of cuts through two parallel lines, so we can say the alternate interior angles are going to be congruent. We could also prove these guys over here are congruent. So technically all three of these were congruent. We're really just working on writing similarity statements. I'll just write this in terms of 1, 2, and 3. So that says angle GKH is similar to triangle 1, 2, 3 is going to be NKM is another way to write this. And there's several ways you can write each one of these. It really just depends on where you're at and what you're doing. Exercises here, it says use a diagram at the right, find the coordinates of point Z so that these two triangles are similar. So it says that RO is 0, 0, and then it says S is 0, 4, so basically this entire length here is 4, over 0 up 4. T is going to be -8, so that's going to give us a length of 8. X is over 2, and then let's see, we have to find where Z is at. So we have to figure out where this point here is at. I'm sorry, X is up 2, not right there. We're trying to figure out this length here, so ignore that. Okay, so if this big triangle is up 4, and this is only up 2, that means this triangle here is going to be half as long. So if this is 8, this has to be a distance of 4. So I would say Z would have to be over 4 up 0. Okay, so that's what X and Y are for number 18. I'll erase this for the next problem. Erase a little bit more. And what I'm looking at now is I'm looking at R being 0, 0, S being 0, 6. So that means that that's up 6. T is over 6, so it's going to be some sort of isosceles triangle. X, again, is up 2. So this has to also be an isosceles triangle, so it also has to be 2 as we go there. So that means that this is going to be a relation of over 2 up 0. Last problem for us, it says in order to estimate the height of a flagpole, a 5-foot tall male student stands so the tip of his shadow coincides with the tip of the flagpole's shadow. This scenario results in two similar triangles and is shown in the diagram. You probably did something like this in Algebra 1 class a while ago. It is a similarity problem. It is an Algebra 1 type problem. But first question, why are the two overlapping triangles similar? It has to do with the sun. The sun is up here somewhere, shining down, and because of the shadow made here and the 90-degree angle, and the shadow coming down this way and the 90-degree angle, the angle of the person in the shadow and the flagpole, this angle is going to be the same as this angle here, and this 90-degree angle will be the same angle as this one. So the reason is because of the angle-angle similarity postulate, because of the way that the angle that the sun makes with the flagpole and the sun makes with the person. You could also talk about alternate interior, corresponding angles this way, once you know both those are 90-degree angles. Using the similar triangles, write a proportion that models the situation. So we'll basically talk about the height of things. And we'll talk about sort of like the, I guess we could talk about the distance from like A. Okay, and we'll talk about two things. We'll talk about the person, and we'll talk about the flagpole. I guess I could have just said the flag or the pole. So the height of the person is 5 feet. The height of the flagpole is going to be h. the distance of the person from A is going to be 6. The distance from the A to the flagpole is not just 6, it's not just 12, it's actually 6 plus 12, so that'll give us 18. Okay. When we cross multiply, we would have 90 equals 6h. 90 equals 6h. We divide both sides by 6, and h equals 15. We'll label it with feet. And that seems like this is a 5-foot person. 15 feet tall sounds like a pretty good measurement for a flagpole. Okay, you can have many of these problems. I usually use some sort of box method. You're talking about two people or two items, a person and a flagpole, and there's two attributes, sort of their height of the person and the flagpole, and sort of a distance from A. Generally speaking, it's a good way to set this up. Not a bad idea to write these guys out so we know what we're talking about when we set up our proportions. Okay, again, it said to solve for it, make sure it's in feet, we should be good. In review, we looked at looking at these different pieces and similar triangles and kind of using those to find missing variables. We talked about writing similarity statements. Remember, when you write similarity statements, the first term always has to have the same angle as the first term, the last one with the last one, and the middle one with the middle one. Make sure those match up. You're going to use a triangle sum theorem quite a bit with those types of problems. In this part right here, what we're going to use is we're just basically setting up writing similarity statements. Can you write a statement of proportionality, fill in the blanks, what's associated with what? Because of angles, remember that similar triangles have congruent angles and their sides are going to be proportional, and we're actually going to set up some proportions in order to solve for variables. This is our lesson. It all deals with this angle-angle similarity postulate. Once you have two angles, then you can find the third one and prove that two triangles are similar.